Welcome to Cosmic Bedtime, where the mysteries of the universe become gentle stories to drift away with. Tonight, we'll journey beyond the stars, into questions that have puzzled scientists and dreamers alike. Lay back, close your eyes, and let the cosmos guide you, because sometimes, the best way to fall asleep is to wonder about the universe. On a warm summer night in August of 1977, the world of science received a whisper from the universe. It was not a bright flash of light streaking across the sky, not a comet or meteor blazing into Earth's atmosphere, but something far quieter, so quiet that it could only be heard by one of the most sensitive instruments of its time. The sound was not a melody, nor even a voice, but a narrow band of radio waves, rising above the cosmic background like a single note emerging from an endless ocean of silence. It lasted for just 72 seconds. And then, it was gone. This fleeting message, recorded by the Big Ear radio telescope at Ohio State University, would come to be known by 3 simple letters and 1 exclamation mark: the wow signal. Its name arose from the astonished reaction of astronomer Jerry Eman, who circled the strange numbers and letters on the printout and scrawled his spontaneous comment in red ink: "Wow." That moment, half a century ago, continues to echo in our collective imagination, as if those 3 letters were the universe itself leaning close to us and whispering, "You are not alone." But what was the wow signal, really? To appreciate its significance, we must travel back into the atmosphere of the 1970s, when the dream of discovering extraterrestrial intelligence was alive in both scientific laboratories and in the imaginations of ordinary people gazing up at the stars. The 1970s were a time of transition for humanity. We had already taken our first steps onto the moon. The Apollo astronauts had looked back at Earth from space and described it as a fragile blue marble drifting through blackness. Voyager 1 and 2 had just launched on their grand tour of the outer planets, carrying with them golden records engraved with sounds and images of Earth, a message in a bottle sent into the cosmic ocean. Amid this backdrop of exploration, the search for extraterrestrial intelligence, or SETI, was quietly blooming. SETI was built on a simple but profound question: if life could evolve on Earth, why not elsewhere? And if intelligent beings had arisen among the stars, might they not also be sending signals, intentionally or unintentionally, across the cosmos? Perhaps they, too, were curious. Perhaps they, too, wanted to know if they were alone. The Big Ear radio telescope in Ohio was one of the instruments listening. It did not look like the iconic dishes we imagine today. Instead, it stretched across the ground like a giant ear pressed against the sky, a flat, rectangular surface of metal mesh reflecting radio waves into a receiving system. Patiently, day after day, it swept the heavens, converting the faint murmur of the universe into streams of data printed out on long rolls of computer paper. Most of what it recorded was noise: the hum of our own planet, the crackle of distant pulsars, the hiss of the Milky Way. But once, on August 15, 1977, something unusual appeared. The printout contained a series of alphanumeric characters, each one representing the strength of a radio signal. Normally, the numbers stayed small, hovering in the low single digits. But in one column, a sudden spike leapt out: 6EQUJ5. To Jerry Eman, poring over the paper, it was instantly clear that this was extraordinary, a signal far stronger and narrower than ordinary background noise. In the margin, unable to contain his astonishment, he scribbled that immortal word, "Wow." Imagine, for a moment, what that discovery must have felt like. The laboratory lights buzzing softly. The smell of warm electronics. The endless sheets of paper flowing out of the printer. And then, in the midst of ordinary data, this singular event. A spike. A shout in the silence. A voice in the cosmic dark. Could it be, at last, evidence of an intelligence beyond Earth? The wow signal lasted just 72 seconds, the exact length of time that the Big Ear telescope could observe a single spot in the sky as the Earth rotated. And then, like a dream fading upon waking, it vanished. Astronomers searched again and again, returning to the same patch of sky, straining their instruments to listen for a repeat. But it never came. That silence, paradoxically, is part of what has made the wow signal so haunting. If it had repeated, if it had behaved like a natural phenomenon we could study, perhaps the mystery would have been solved long ago. But it didn't. It appeared once, as if peeking around the corner of the universe, and then slipped away, leaving us to wonder. Where did it come from? The signal was traced to the constellation Sagittarius, near the center of the Milky Way. It was narrowband, meaning it occupied a very specific frequency, around 1420 MHz, the so-called hydrogen line, a frequency associated with the most abundant element in the universe. Many scientists had speculated that if extraterrestrials wanted to communicate, they might use this frequency as a kind of cosmic common ground. And here, right at that frequency, the wow signal appeared. Coincidence? Or was it a deliberate choice? The mystery deepens when we realize just how difficult it is to explain the wow signal away. Some have suggested it might have been a reflection of Earth-based signals, perhaps from satellites or aircraft. But careful analysis has never found convincing evidence. Others propose that it could have been a natural cosmic phenomenon, like a comet or a burst of radiation. And yet, none of these explanations fit neatly. So, for half a century, the wow signal has remained suspended between possibilities. Perhaps it was a mundane event we simply don't understand yet. Or perhaps, just perhaps, it was a brief hello from across the stars, a wave from another intelligence as curious about us as we are about them. The beauty of the wow signal is not only in its scientific puzzle, but also in its poetry. It invites us to sit at the edge of our beds at night, staring out the window at the stars, and to wonder, is someone out there, looking back? Are we listening to the same silence, separated only by distance, waiting for the courage to speak again? 50 years later, the wow signal still feels less like a solved equation and more like a dream, an unfinished sentence written across the sky. Its story begins not just in the data room of a telescope in Ohio, but in our own hearts, in that fragile, persistent hope that we are not alone in the universe. And as we drift now into the story of this cosmic enigma, let us hold on to that moment of wonder, the trembling of Jerry Emmons' hand as he wrote, "Wow," the gasp of possibility that followed, and the sense that somewhere, just beyond our reach, a signal had crossed the void and touched us. Perhaps it was an accident. Perhaps it was a star. Perhaps it was a civilization calling out into the dark. We may never know. But the memory of that single 72-second song still glows like a candle in the vast night, a reminder that the universe is larger, stranger, and more mysterious than we can ever fully grasp. So tonight, as we begin our journey into the Wow Signals story, imagine yourself lying under the stars, the cool night air brushing your face, and the silence of the cosmos stretching endlessly above. Somewhere out there, a signal was sent, received, and lost. And in that fleeting moment, humanity was given a gift, not an answer, but a question. A question that still waits, 50 years later, for us to dream upon. When people imagine a radio telescope, they often picture a giant dish, gleaming silver beneath the sky, angled like a great ear toward the heavens. The truth is, telescopes come in many shapes and sizes, and one of the most unusual of them all was a structure in Ohio that earned the name the Big Ear. It was here, on a quiet August evening in 1977, that the famous Wow signal was captured. But to understand the mystery of that moment, we must first take time to know the place where it happened. The Big Ear was not glamorous. It was not built to impress tourists or to dazzle with sleek design. Instead, it resembled a giant field of metal mesh stretched across the ground, with two vast reflectors standing like silent walls at either end. One reflector, nearly as tall as a 10-story building, stood vertical, while the other lay tilted, catching the sky's whispers and bouncing them into a receiving system. There was no dome, no elegant curves like those of more famous observatories. Instead, it looked a little like an enormous drive-in movie screen, paired with a strange patch of industrial farmland. And yet, this ungainly structure was one of the most sensitive instruments of its time. The Big Ear was built not for beauty, but for patience, for listening. Its vast surface gathered the faintest radio signals drifting down from space, funneling them into detectors that translated cosmic whispers into streams of numbers. Night after night, day after day, it scanned the heavens with quiet persistence. The Big Ear was the creation of Dr. John D. Krause, a physicist and engineer at Ohio State University. Krause was a dreamer, but also a builder. He believed that radio astronomy, the study of the universe through radio waves, was a frontier just as thrilling as any rocket or space mission. While others focused on telescopes that studied visible light, Krause knew that much of the universe remained invisible to the human eye. Stars, galaxies, nebulae, and perhaps even civilizations might speak in radio. To hear them, humanity needed ears tuned to those frequencies. So, with limited funding but endless ingenuity, Krause and his team constructed the Big Ear in the 1960s. It was not a glamorous project. Students hauled mesh, bolted frames, adjusted wires, and improvised solutions as best they could. Piece by piece, the telescope grew on a patch of land near Delaware, Ohio, a quiet town surrounded by fields and farms. To neighbors, it must have seemed an odd thing indeed, a metallic field shimmering under the sun, humming quietly as it watched the sky. But to Krause and his team, it was a portal to the universe. For more than a decade, the Big Ear was used to create one of the most ambitious sky surveys ever attempted. Its mission was to map radio sources across the heavens, cataloging the invisible landscape of the cosmos. Stars that blazed too faintly for our eyes could still shout in radio. Quasars, galaxies with black holes at their hearts, poured out torrents of energy. Supernova remnants glowed in frequencies we could never see. The Big Ear recorded them all, patiently building a map of a universe richer and more complex than any visible star chart. But the big ear had another purpose, one even more daring. In the early 1970s, Krauss allowed his telescope to join a new and risky endeavor, the search for extraterrestrial intelligence, or SETI. The idea was simple yet radical. If intelligent civilizations existed elsewhere in the galaxy, perhaps they would send signals we could detect. Perhaps, among the natural static of space, there might be an intentional beacon, a hello, drifting across the void. To many, this sounded fanciful, even foolish. But Krauss and his colleagues believed it was worth listening. After all, the cost was low, the telescope was already scanning the sky. And if there was even a chance, however slim, of hearing another civilization, wasn't it worth trying? Thus, the big ear became one of the world's first dedicated instruments in humanity's search for company among the stars. The design of the telescope gave it both strengths and quirks. Unlike steerable dishes that could turn to follow an object, the big ear was fixed in place. It relied on Earth's rotation to sweep its gaze across the heavens. Each day, as the planet spun, the telescope's field of view traced a narrow line across the sky. A particular patch of space could be observed for just 72 seconds at a time, the precise window during which the wow signal appeared. If something interesting was found, the telescope could not turn back to look again. The sky would move on, the signal would pass, and all that would remain was the record on paper. That was both the beauty and the frustration of the big ear. It was an instrument of patience, not immediacy. It could not chase phenomena. It could only wait for the universe to speak, and then record whatever whispers arrived. Inside the control room, the big ear's data emerged not on glowing computer screens, but on long sheets of dot matrix printouts. The telescope converted radio signals into streams of numbers and letters, coded to indicate signal strength. Most of the time, these sheets were monotonous, rows upon rows of small values, a quiet background hum. Students and researchers would sort through them, sometimes late into the night, searching for anomalies. It was on one such sheet, in 1977, that Jerry Emin, a volunteer for the SETI project, discovered the series of characters that would become legendary, 6EQUJ5. To him, those 6 symbols leapt off the page, unmistakably stronger than the noise around them. They were the fingerprint of something unusual, something powerful, something that might not be natural. Unable to contain his reaction, he scrawled, "Wow," in red ink beside them. That single word would immortalize both the signal and the telescope that heard it. Suddenly, the ungainly big ear in Ohio was famous. It was no longer just a quirky structure hidden among cornfields. It was the place where humanity may have, for the first time, brushed against another intelligence. The big ear would continue operating for decades after the wow signal, contributing to both astronomy and SETI. Its metal mesh grew weathered, its equipment aged, but it remained steadfast, sweeping the sky with quiet dignity. Researchers came and went, generations of students learned their craft beneath its framework, and the telescope endured as a patient sentinel of the cosmos. But time is not kind to even the greatest instruments. By the 1990s, funding was scarce, and the land on which the big ear stood had grown valuable. In 1997, just 20 years after it captured the wow signal, the big ear was dismantled to make way for a golf course. The field of mesh was torn away. The great reflectors were brought down. Where once a telescope had listened to the stars, golfers now walked in search of quiet afternoons. And yet, though the big ear is gone, its legacy endures. It gave us one of the most tantalizing mysteries in the history of science. It showed that even with modest resources, built by students and maintained with perseverance, we could touch the universe in profound ways. It proved that listening can be as bold as launching rockets, that patience can yield wonders as great as discovery. When we think of the big ear now, we do not remember its awkward shape or its eventual demolition. We remember the night it heard something extraordinary. We remember the data sheet with red ink scrawled across it. We remember that for 72 seconds, on an August evening, the universe seemed to lean close to a humble telescope in Ohio and whisper a secret. The big ear was more than steel and mesh. It was a symbol of humanity's longing. A farm field turned into a cosmic ear, a humble structure turned into a dream. It stood as a reminder that the search for knowledge does not always begin with grand monuments, but with curiosity, persistence, and the courage to listen to silence. Tonight, as we continue our journey into the wow signal, let us pause to honor the big ear. Though it no longer stands, its story continues in every conversation we have about the possibility of other civilizations. It is alive in the questions we ask, in the wonder we feel when we look up at the night sky, and in the enduring mystery of the signal it captured. The big ear listened to the universe with patience and humility. And in return, for one brief, shining moment, the universe answered back. When we talk about the wow signal, it is not just the romance of the story that captures our imagination. It is not simply the image of a lone volunteer in the 1970s circling strange characters on a printout. What makes this signal unforgettable is the fact that, even after nearly 50 years of study, it stands apart. It was not just a random burst of static, not a common blip like countless others seen in radio astronomy. The wow signal had qualities that made it different. To understand why, we must first take a small step into the world of radio astronomy itself. Imagine the night sky, but not with stars glittering as points of light. Instead, imagine it filled with a constant ocean of sound. Not sound as our ears perceive it, but waves of radio energy washing through space. Stars hiss faintly. Pulsars beat rhythmically, like cosmic metronomes. Distant galaxies emit a soft hum. And in between all of these are bursts of noise, lightning on Earth, interference from satellites, even signals from our own technology. To a radio telescope, the sky is alive with chatter. The problem, and the challenge, is sorting out what is natural, what is human-made, and what might be something more. Most of the time, the answer is simple: natural sources or human interference. But once in a while, a telescope stumbles across something that refuses to fit neatly into either category. The wow signal was one of those rare anomalies. It was not just another spike in the data. Its strength, its duration, its frequency, and its sheer clarity all combined to make it extraordinary. Let us begin with its power. On the printout, the signal was recorded as 6EQJ5. These characters were not random letters, but part of a code used to represent signal intensity. Most background noise hovered near the lower end of the scale, producing values like 1 or 2, sometimes 3. But the wow signal climbed dramatically, peaking at the letter U, which corresponded to a value of 30. To put this into perspective, that meant the signal was roughly 30 times stronger than the normal background noise. This was not a faint whisper on the edge of detectability. It was a sudden, clear shout rising out of the static. To Jerry Eman, the volunteer who first spotted it, that jump in intensity was unmistakable. He had scanned countless printouts filled with dull, repetitive numbers. But this was something different. Strength alone might not be unusual, after all, strong signals do occur. But what made the wow signal remarkable was that it matched the expected behavior of something narrow and focused, something not likely to be random noise. The signal lasted for precisely 72 seconds. That number is not arbitrary. It was the exact amount of time that the Big Ear telescope could observe a point in the sky as Earth rotated. The telescope was fixed, remember, and could not swivel to track objects. Instead, as the planet spun, a target source would drift through its field of view, like a bird crossing the beam of a flashlight. For any celestial signal, the maximum window would be 72 seconds. And that is exactly what the wow signal did. It appeared, it grew in strength, it reached a peak, and then it faded away, all over a span of about 72 seconds, mirroring perfectly the way a true signal from the stars should behave. This smooth rise and fall mattered enormously. Random interference from Earth-based sources tends to behave differently. It often cuts in abruptly, stutters, or remains longer than expected. But the wow signal behaved like something truly astronomical, drifting with precision through the Big Ear's listening beam. Perhaps the most tantalizing quality of the wow signal was its frequency. It was centered around 1420 MHz, also known as the hydrogen line. Hydrogen is the most abundant element in the universe. At 1420 MHz, neutral hydrogen atoms naturally emit radiation, producing a universal marker in the radio spectrum. Astronomers often use this frequency to map the structure of galaxies, since hydrogen gas clouds fill interstellar space. But here is where the story grows intriguing. Many scientists involved in SETI have long speculated that if another civilization wanted to send a signal into the cosmos, they might choose the hydrogen line. Why? Because it is universal, fundamental, and obvious to anyone studying the universe. It is, in a sense, a natural hailing frequency, a place where any technologically advanced species might expect others to listen. The wow signal, then, was not just strong, not just perfectly timed, it was also whispering on one of the most meaningful frequencies in all of astronomy. If you were designing a cosmic beacon to say, hello, you could hardly choose a better spot. Another striking aspect was its clarity. The wow signal was narrowband, meaning it occupied a very small range of frequencies. Most natural sources of radio waves, like stars or nebulae, spread their emission broadly across the spectrum. They are like bonfires, glowing across a wide swath of color. A narrowband signal, by contrast, is more like the sharp beam of a laser. It suggests precision, focus, and in many cases, artificiality. This is one of the reasons the wow signal stood out. It did not behave like the broad, messy emissions of nature. Instead, it looked like something tightly tuned, something made. And yet, for all its qualities, the most haunting feature of the WOW signal is that it was never heard again. After its discovery, astronomers rushed to re-observe the same region of the sky. The Big Ear listened. Other telescopes joined the search. Years passed, and surveys returned again and again to the coordinates near Sagittarius, where the signal had appeared. But there was nothing. The WOW signal remained a singular event, never repeated, never confirmed. This is perhaps the greatest mystery. If it was simply human interference, say, a stray signal from an aircraft, a satellite, or a military transmission, then why was it never repeated? Interference usually recurs, because human technology operates persistently. If it was natural, why did it match so perfectly the signature of an artificial transmission? And if it was truly extraterrestrial, why just once? For decades, scientists have debated possible explanations. Some argue it might have been a rare reflection of Earth-based signals bouncing off space debris. Others suggest it could have been a transmission from a passing spacecraft, though no known craft was in range at the time. Some even propose natural astrophysical phenomena we do not yet fully understand. But none of these explanations satisfy completely. Each has holes, inconsistencies, or lacks supporting evidence. Which is why, half a century later, the WOW signal still resists being filed neatly away as either natural or artificial. The WOW signal endures because it represents possibility. It is the one time in all of human history when a signal arrived that ticked so many of the boxes we would expect if another intelligence were trying to reach us. Stronger than background noise. Perfectly timed with Earth's rotation. Narrowband in character. Located at the hydrogen line frequency. And utterly unexplained. It was, in other words, exactly the kind of signal SETI had always hoped to find. But without repetition, without confirmation, science cannot claim it as proof. Instead, it remains suspended in mystery, an unfinished sentence in the language of the cosmos. Think of it this way: if you were walking alone in a dark forest, and suddenly you heard your name called clearly, just once, and then never again, how would you feel? That is what the WOW signal is to humanity. A single clear call, unmistakable and strange, and then silence. Was it a trick of the wind? An echo from your own mind? Or was it something real, someone else sharing the forest with you? The WOW signal sits exactly in that space. It is not enough to prove contact, but too remarkable to dismiss. It lingers in our imagination because it feels like a glimpse, however fleeting, of something greater. In the decades since, astronomers have recorded countless signals, bursts, and anomalies. Some were later explained as satellites. Some were traced to pulsars or quasars. Others turned out to be simple technical glitches. None, however, have matched the elegance and mystery of the WOW signal. It remains unique, a singular event standing apart in the annals of SETI. That uniqueness is what makes it both frustrating and beautiful. Frustrating, because science thrives on repetition and evidence. Beautiful, because it leaves room for wonder. The WOW signal is not proof, but it is possibility. It is not an answer, but it is a question, one that continues to echo across generations of scientists, dreamers, and stargazers. As we reflect on what made the WOW signal unique, we see that its power was not just in numbers or frequencies. Its power was in the way it captured imagination. It was a scientific anomaly, yes, but also a story of listening to the universe and, for one brief moment, hearing something extraordinary. Perhaps one day we will find another signal. Perhaps it will come stronger, clearer, and repeat itself until doubt is gone. Or perhaps the WOW signal will remain forever a lone whisper, a mystery carried in the silence between the stars. Either way, its uniqueness is undeniable. For 72 seconds, the universe spoke in a voice unlike any we had ever heard. And that, more than anything, is why we still remember it. When Jerry Emmon first circled those cryptic numbers and letters on the Big Ears printout in August of 1977, his astonished scrawl of "Wow" was not just the reaction of one man, it was the spark that would ripple outward into the collective imagination of humankind. What began as an ordinary evening shift in a modest observatory in Ohio soon blossomed into one of the most talked about scientific mysteries of the modern age. This is the story not just of a signal, but of the people who received it, pondered it, debated it, and dreamed about it. The human reaction to the WOW signal, in many ways, has become as fascinating as the signal itself. Imagine being Jerry Emmon on that night, a volunteer researcher, sifting through pages of alphanumeric code. Each row and column represented streams of data, carefully printed by the observatory's computers. For hours, the task must have been monotonous, like fishing in a vast sea of static, waiting for a glimmer of something unusual. And then, there it was. A sequence so starkly different from the rest of the noise that it almost leapt off the page. When he circled those characters and wrote, "Wow," Jerry likely had no inkling that this small gesture would one day symbolize one of the greatest cosmic mysteries in human history. At first, it was just a scientist's shorthand, a note of excitement to mark an anomaly. But that little word was powerful. It captured awe, surprise, curiosity, and maybe even a hint of disbelief, all in one short exclamation. When news of the strange detection began to circulate, Emmon himself was cautious. He knew the importance of skepticism in science. Was this an equipment malfunction? A satellite passing by? A signal from Earth bouncing in an unusual way? But despite his hesitations, the very possibility that it could be something more, a message from the stars, was enough to stir excitement among his colleagues. Soon, the story left the quiet walls of the Big Ear Observatory and reached the wider world. Journalists, always eager for a story that combined mystery with wonder, quickly latched onto the WOW signal. Headlines framed it in dramatic terms: alien message from the stars. Scientists record possible signal from extraterrestrials. In the late 1970s, during the golden age of science fiction cinema, when Star Wars and Close Encounters of the Third Kind captured imaginations worldwide, the idea that scientists had heard from aliens seemed almost too perfect. For many in the public, the WOW signal became an irresistible story. It was something real, something tangible, a scientific detection that might prove humanity was not alone. To a culture already fascinated with UFOs, space exploration, and the possibility of life beyond Earth, this signal was fuel for dreams. Coffee shop conversations, newspaper letters, and radio call-in shows buzzed with speculation. What if this was the proof we had been waiting for? Of course, not everyone reacted with unbridled excitement. Many scientists urged caution, as Emin himself had done. They reminded the public that science requires repeatability. A single signal, observed only once and never again, was not enough to prove anything conclusive. They compared it to seeing a flash of light in a dark forest. Was it a lantern, a reflection, or just lightning? Without a second observation, how could one know? For skeptics, the wow signal was intriguing, but insufficient. They speculated about terrestrial explanations, perhaps a satellite transmission, perhaps interference, perhaps a natural cosmic phenomenon not yet understood. Their voices were important, grounding the conversation in scientific humility. And yet, even their measured tones could not extinguish the spark of wonder. If anything, the skepticism only added to the mystery. People are often drawn more strongly to questions without answers than to those with neat resolutions. Over time, the wow signal grew beyond its status as a scientific anomaly. It became a cultural symbol. The simple word, wow, written in red ink came to embody humanity's yearning for connection with the cosmos. Artists painted it, musicians referenced it, authors used it as inspiration. It appeared in documentaries, novels, even tattoos on the arms of space enthusiasts. For many, it represented a doorway into imagination, the tantalizing idea that someone, somewhere, might have been trying to speak to us. This was no ordinary piece of data. It had an aura, a mystique. In a world where so many signals are meaningless static, this one was different. It stood apart. And that difference invited people to dream. For the scientists directly involved, however, the reaction was more complicated. Jerry Emin, for instance, often expressed frustration in later interviews when the signal was overstated as proof of aliens. He knew better. He understood the fragility of evidence and the importance of rigor. For him, the wow signal was an unsolved puzzle, fascinating, yes, but unresolved. He resisted the urge to leap to conclusions, even as the world wanted him to. Other researchers in the SETI, Search for Extraterrestrial Intelligence, community shared this mix of wonder and caution. On one hand, the signal was the most compelling candidate ever recorded. On the other, science demands more than just a single data point. The frustration of not being able to redetect it weighed heavily. They kept scanning the skies, listening, hoping for a repeat performance that never came. And yet, even in their caution, many of them admitted to being moved. To work your whole career sifting through silence, and then to find even one moment of possible contact, it changes you. It reminds you why you started listening in the first place. In the decades that followed, the wow signal wove itself into the tapestry of popular culture. It was featured in television shows about mysteries of the universe, in science museums, and in endless online discussions. Conspiracy theorists embraced it, spinning tales about government cover-ups. Science fiction writers used it as a seed for stories about humanity's first contact. Philosophers reflected on its meaning. What does it say about us, that we are so quick to interpret a signal as a message? For the average dreamer staring at the night sky, the wow signal was a source of comfort. It was a reminder that the universe might be more alive, more filled with possibilities, than we dare imagine. And for those who loved to wonder before falling asleep, it became a story to drift into dreams with. Maybe, just maybe, we are not alone. The human reaction to the wow signal spans the full spectrum of emotions. There is awe, the sheer wonder of possibly hearing from the stars. There is skepticism, the sober reminder that evidence must be tested. There is frustration, that no one has ever heard it again. And there is hope, that someday, somewhere, we might catch another signal, clearer and stronger than before. Together, these emotions form a rich tapestry of what it means to be human. We are creatures who yearn, who question, who doubt, and who dream. The wow signal did not just touch our instruments, it touched our hearts. In the end, perhaps the most profound aspect of the human reaction is what it reveals about us. The signal itself is just a sequence of numbers and letters on a page. But the way we respond, turning it into art, debate, philosophy, and longing, shows that we are, at our core, a species hungry for connection. Whether the signal was truly from extraterrestrials or just an earthly echo, it became a mirror reflecting our deepest desires. We want to know we are not alone. We want to know that our story is part of a greater cosmic tale. And even a fleeting signal, lasting only 72 seconds, is enough to ignite that hope. As the years rolled by, the human reaction to the wow signal did not fade. If anything, it deepened. Like a haunting melody heard only once, it lingered in memory. For scientists, it became a call to keep searching. For dreamers, it became a bedtime story whispered by the universe. For humanity as a whole, it became a reminder that sometimes the greatest gifts are not answers, but questions. And so, when we look back at the wow signal 50 years later, we are not just remembering data collected by a radio telescope. We are remembering the thrill of wonder that swept across a planet. We are remembering how, for a moment, we all looked up together, imagining the possibility that someone, somewhere, might have been saying hello. The wow signal may have lasted only 72 fleeting seconds, but its echo has lingered for decades. For scientists, dreamers, and believers alike, the question has never truly been whether the signal was real. It was real, an authentic detection recorded by the Big Ear telescope in 1977. The deeper question has always been, what was it? This mystery has driven 50 years of searching. Searching the skies. Searching the archives. Searching our theories. Searching our own imaginations. The wow signal became not just an event, but a quest, a collective effort to peel back layers of noise and uncertainty in hopes of finding clarity. Let us drift now through this half-century of searching for answers, as astronomers, engineers, skeptics, and storytellers all took their turn at chasing the elusive truth. When the signal was first noticed, the natural reaction was simple: point the telescope back in the same direction and listen again. Jerry Eman and his colleagues did just that. Within days, they redirected the Big Ear toward the coordinates where the signal had been strongest. If this was truly an extraterrestrial transmission, surely it would repeat, or at least persist. But silence. The Big Ear listened. The operators waited. And nothing came. Like an echo fading into the night, the signal had vanished as mysteriously as it had appeared. This was both exciting and frustrating. Exciting, because it suggested the signal was unusual. Frustrating, because science thrives on repetition. Without a second detection, proving anything would be nearly impossible. For years afterward, the Big Ear and other observatories continued scanning that patch of sky, hoping the signal might return. But it never did. It was like glimpsing a shooting star that streaks once across the heavens, never to appear in quite the same way again. The wow signal became a rallying cry for the search for extraterrestrial intelligence, SETI. Though researchers had been listening for signals since the 1960s, the wow detection gave SETI a story, something concrete they could point to when asked why the search mattered. The 1980s and 1990s saw the development of more sophisticated listening equipment. Computers grew faster. Telescopes became more sensitive. Entire networks of volunteers, through projects like SETI at Home, began contributing their computing power to sift through data. The wow signal was always there in the background, like a lighthouse reminding them why the search was worth continuing. Yet despite billions of stars scanned, trillions of radio frequencies analyzed, nothing quite like the wow signal appeared again. Patterns of interference were found. Pulsars revealed themselves. Bursts of cosmic radio waves were catalogued. But no other event carried the same sense of possibility. As the years stretched on, skeptics began to sharpen their arguments. If the signal never repeated, was it fair to suggest it came from aliens? Couldn't it have been something more ordinary, even if mysterious? Some researchers suggested it might have been a satellite passing overhead. Others argued for radio interference bouncing off the ionosphere. Still others proposed natural cosmic phenomena, comets, hydrogen emissions, even microwave bursts from distant quasars. The comet hypothesis in particular gained attention in the mid-2010s, when a researcher suggested that hydrogen clouds surrounding comets 266P/Christensen and 335P/Gibbs could have produced the signal. These comets happened to be near the signal's coordinates in 1977. Perhaps the Big Ear had simply picked up natural radio emissions as the comets drifted past. But critics pointed out that comet emissions are generally weak, far weaker than the wow signal's intensity. And the frequency, the famous 1420 MHz hydrogen line, was oddly precise, exactly the spot astronomers had theorized extraterrestrials might choose to transmit, since hydrogen is the most abundant element in the universe. Could comets really explain that? The debates raged on. Each new explanation seemed to solve part of the puzzle, but never all of it. In the 21st century, the wow signal has continued to inspire new listening campaigns. Projects like Breakthrough Listen, funded by tech billionaires and supported by some of the world's largest radio telescopes, have scanned the skies with unprecedented sensitivity. These programs have targeted the same region of the constellation Sagittarius where the wow signal was heard, searching with equipment millions of times more powerful than Big Ears. And still, silence. But the silence itself tells a story. It tells us that if the wow signal was artificial, it was not a beacon that repeats constantly. Perhaps it was a passing whisper, a test, or an accidental transmission. Or perhaps it truly was natural, and we have yet to fully understand its source. Beyond the technical investigations, the search for answers has been just as much human as scientific. For every astronomer poring over spectrograms, there is a dreamer staring at the stars, asking, "What if?" The wow signal has inspired novels, documentaries, podcasts, songs, and even video games. It has been painted on murals, printed on t-shirts, etched into jewelry. The very act of searching for answers became a kind of cultural ritual, an acknowledgement that we are creatures who long to know, even when answers prove elusive. In reflecting on decades of searching, scientists often highlight several key lessons. 1. The universe is noisy, but rare signals stand out. Most of what radio telescopes hear is cosmic static. But every so often, something unusual cuts through. The wow signal showed how important it is to keep listening. 2. Technology matters. The big ear was revolutionary in its time, but crude compared to today's tools. Each leap in computing and telescope design has expanded the search. If the wow signal happened today, we might have recorded far more details. 3. Mystery is valuable. Even without answers, the wow signal has fueled curiosity, funding, and passion for SETI. Sometimes the greatest contribution of an anomaly is not in solving it, but in inspiring others to keep looking. Is the mystery doomed to remain unsolved forever? Not necessarily. The universe is vast, and our tools are growing stronger each year. Some scientists argue that if the wow signal truly was an extraterrestrial transmission, we may detect something similar again, if we keep searching long enough. Others suggest that re-examining old archives with modern techniques might reveal overlooked signals. Machine learning, for instance, is now being used to scan decades of radio astronomy data with fresh eyes. It is possible that somewhere, buried in the static of past recordings, another wow-like event waits to be uncovered. The quest for answers has also expanded beyond radio astronomy. Scientists now search for techno-signatures of all kinds, signs of advanced civilizations not just in radio waves, but in optical lasers, infrared emissions, even unusual patterns of exoplanet atmospheres. The wow signal taught us that the search cannot be narrow. If someone out there is trying to be noticed, they might not be using only radio. They might shine lasers into the cosmos. They might leave signatures in their planetary chemistry. They might even use methods we have yet to imagine. The wow signal, then, was not just a puzzle. It was a catalyst to widen our thinking about what contact might look like. As we sit tonight, 50 years after that fateful summer evening, the wow signal remains unresolved. Scientists have chased leads, tested theories, improved instruments, and scoured the sky. And yet, the heart of the mystery endures. Was it aliens? Was it natural? Was it simply human interference, misunderstood? We do not know. But perhaps the most important truth is this: the search for answers is never wasted. In looking, we learn. In questioning, we grow. And in wondering, we remain alive to the vastness of the universe. So if you find yourself staring at the stars tonight, Think of that moment in 1977 when a faint whisper seemed to call from the depths of Sagittarius. Think of the astronomers who have spent their lives listening for echoes. Think of the billions of people who have dreamed because of it. The wow signal may never give up its secrets. But in chasing it, we discover something even more profound, our own unshakable desire to know if we are alone. And that desire, that endless search, is, in itself, a kind of answer. The wow signal, though fleeting, left a trail of wonder behind it. Like a riddle whispered by the cosmos, it has invited scientists, dreamers, and skeptics alike to fill in the silence with explanations. Some of these explanations are grounded in careful analysis, others in bold imagination. Together, they form a tapestry of possibilities, some mundane, some extraordinary, and some that blur the boundary between science and myth. For nearly 50 years, the world has asked, what was the wow signal? Let us drift through the many theories and speculations, from the cautious to the daring, each one a reflection not only of cosmic mystery, but also of our human yearning to make sense of the unknown. The most straightforward explanations have always been natural. The universe is not a quiet place. Stars erupt in flares. Pulsars beam radio waves like cosmic lighthouses. Gas clouds hiss faintly across the electromagnetic spectrum. To some, the wow signal was simply a rare alignment of natural phenomena, amplified in just the right way to trick us into thinking it was intentional. Pulsars, rapidly spinning neutron stars, emit beams of radiation that sweep across the sky like cosmic beacons. Quasars, the blazing hearts of galaxies powered by supermassive black holes, shine intensely across wavelengths. Could the wow signal have been such an object caught at just the right frequency? The challenge is that pulsars and quasars usually produce broad signals, not narrow ones. The wow signal was sharp, laser-like, focused right on the hydrogen line at 1420 MHz. It didn't look like natural, static. It looked deliberate. Another idea points to vast hydrogen clouds drifting through space. Since hydrogen is the most abundant element, its emissions dominate the radio spectrum. Perhaps the big ear simply picked up a natural burst from such a cloud. Yet astronomers have studied hydrogen for decades. Its radio signature is well known. The wow signal didn't look like a normal hydrogen emission, it was too strong, too precise, too fleeting. Natural origins remain possible. But many astronomers quietly admit, if the wow signal was natural, it was something unusual, not a phenomenon we've fully catalogued. In 2015, a bold new theory emerged. Antonio Paris, a professor of astronomy, proposed that the wow signal might have been caused by comets, specifically 266P/Christensen and 335P/Gibbs. These icy wanderers were passing through the region of sky where the signal was detected in 1977. Comets release clouds of hydrogen as sunlight breaks down their water vapor. Perhaps the big ear had simply picked up radio emissions from these passing cosmic travelers. At first, the idea gained attention. It seemed elegant, a known object, producing a known type of signal, in the right place at the right time. But as other scientists tested the claim, doubts grew. The hydrogen released by comets is diffuse and faint. It is not typically strong enough to produce a signal like wow. And again, the frequency was suspiciously exact, the hydrogen line, the very frequency SETI researchers had long argued aliens might choose. Could it really have been coincidence? Today, most astronomers consider the comet hypothesis unlikely. Still, it added one more layer to the story. Even familiar objects can inspire unfamiliar questions when viewed in just the right way. Another camp suggests the wow signal never came from space at all. Perhaps it was terrestrial, an artifact of human technology, bouncing or leaking into Big Ear's receiver. Radio interference has been the bane of radio astronomy since its birth. Airplanes, satellites, military radar, even microwave ovens can contaminate signals. Maybe in 1977, some earthly transmission snuck into Big Ear's field of view. The difficulty is that the Big Ear was designed with two beams of observation. If the signal had been local interference, both beams should have picked it up. Yet only one did. That suggested the source was distant, not nearby. Still, skeptics argue that we can't entirely rule out interference. A one-off anomaly might have slipped through the cracks. If so, the wow signal was never a cosmic whisper, just a quirk of human noise. And then there is the explanation that stirs both wonder and controversy, that the wow signal was exactly what it seemed to be, an artificial transmission from an intelligent civilization beyond Earth. This interpretation has always been tantalizing because of the details. The frequency. The signal was at 1420 MHz, the hydrogen line. Hydrogen is universal. If an alien civilization wanted to announce its presence, broadcasting at hydrogen's frequency would be a logical choice. It is like posting a message on the cosmic bulletin board where everyone is likely to look. The strength. The wow signal was strong, far stronger than the background noise. It wasn't faint static. It looked like a deliberate broadcast. The narrowband nature. Natural sources tend to spread across frequencies. The wow signal was narrowband, concentrated, as engineered signals often are. Taken together, these qualities fit the very model SETI researchers had imagined when dreaming of first contact. The wow signal was, in many ways, the archetype of what they hoped to hear. Of course, if it truly were an alien message, the big question remains: why only once? Why not repeat? Was it a stray ping, a cosmic experiment, or perhaps an accident? Did we overhear something not meant for us at all? The extraterrestrial hypothesis remains unproven. But it has never been fully dismissed. It hovers, shimmering, like the most beautiful possibility of all. Another speculative idea suggests the wow signal may have been leakage from Earth itself, not interference from a nearby transmitter, but a signal bouncing back to us from the Moon or another reflective surface in space. Radio waves often scatter in surprising ways. A strong Earth transmission, such as for military communications, could have reflected off space debris, an asteroid, or even a comet tail, re-entering the telescope's beam as if from the stars. If true, the wow signal was not alien at all, but an echo of ourselves, a cosmic boomerang carrying our own voice back to us. And then, There are the wilder speculations, ideas that stretch the imagination beyond conventional science. Some wonder if the WOW signal was a passing hello, a probe or spacecraft briefly broadcasting as it moved through our region of space. Perhaps the signal was never meant to repeat because the source itself was transient, here today, gone tomorrow. Others imagine it as part of a beacon network, like lighthouses scattered across the galaxy. We may have caught one flash of the beam as it swept by, but unless we align with it again, it will not repeat for centuries. Still others speculate, half in science, half in philosophy, what if the signal was a test? A single whisper sent to see if anyone noticed. We noticed. But maybe the next step is ours. Theories and speculations endure because the WOW signal refuses to fit neatly into a box. Too strange to dismiss as noise. Too singular to confirm as alien. Too precise to call random. Too brief to explain fully. In that space of uncertainty, human imagination thrives. We weave stories, test models, debate possibilities. Each theory, whether scientific or fantastical, reflects not only on the signal itself but on us, the seekers, the listeners, the storytellers who cannot resist filling silence with meaning. In science, mysteries are usually considered problems to be solved. But the WOW signal has shown another truth, that sometimes, not knowing has value. It keeps the door open. It keeps curiosity alive. It inspires generations of astronomers and dreamers to keep asking questions. Every theory and speculation, whether hydrogen cloud, comet, alien beacon, or cosmic echo, reminds us of the vastness of what we do not yet understand. And maybe that is the real gift of the WOW signal. Not an answer, but an invitation. So tonight, as you close your eyes, imagine the sky as Jerry Emmons saw it in 1977, the constellation Sagittarius, the great galactic center glowing beyond. Somewhere in that vastness, a signal flared, like a voice carried across the dark. We do not know whose voice it was. Maybe nature. Maybe chance. Maybe another mind, reaching out. Theories abound, but the truth is still waiting. And until it is found, we carry the WOW signal with us, not as a solved equation, but as a mystery we love to dream upon. The WOW signal lasted for only 72 seconds. A single minute and 12 seconds of cosmic strangeness, gone almost as soon as it arrived. And yet, in the decades since, that brief whisper from the stars has echoed across human culture, science, and imagination. Its legacy is not a clear answer, nor a solved mystery. Instead, it has become something rarer, a symbol of the human quest to listen, to wonder, and to dream about what might exist beyond our fragile world. The WOW signal remains one of the greatest what-ifs in history, and that lingering uncertainty has given it a power far greater than its short duration might suggest. Let us explore the many ways this single event has left its mark, on science, on the search for extraterrestrial intelligence, SETI, on art and literature, and on the collective imagination of humanity. When Jerry Emmons circled those two characters, 6EQUJ5, on a sheet of computer printout in August 1977, SETI was still young. Radio astronomers had been scanning the skies for only a decade. Many dismissed the effort as a fringe pursuit, something closer to science fiction than rigorous astronomy. The wow signal changed that. Suddenly, there was data, a real, strong, narrowband signal that fit the very criteria SETI had long theorized would indicate intelligent origin. It was not proof, but it was evidence that the search was not foolish. That perhaps, out there, voices truly might exist. In the years that followed, SETI gained new momentum. Funding, though always precarious, was buoyed by public fascination. New projects were launched, the Meta Array, the Serendip program, the Allen Telescope Array. The wow signal became the rallying cry, a reminder that listening was not in vain. Even today, nearly half a century later, every SETI conference returns to it. The signal remains the benchmark, the mystery at the heart of the search. Scientists often describe new detections as wow-like or not wow-like. It is the reference point against which all else is measured. The wow signal also taught scientists a lesson in humility. In an era where people often demand clear answers, the event reminded us that sometimes, the universe refuses to explain itself. Astronomy thrives on long data sets, on repeating phenomena. Supernovae, pulsars, exoplanet transits, these can be studied because they occur again and again. The wow signal did not. Its refusal to repeat frustrated researchers, but it also revealed the limits of human patience. Science must live with uncertainty. Sometimes, one data point is all we get. Sometimes, the cosmos offers only a riddle. This humility has become part of SETI's culture. When skeptics dismiss the search, scientists often reply, "We do not know, and that is exactly why we must keep looking." Beyond the scientific community, the wow signal has inspired countless dreamers. Students have written essays and dissertations about it. Artists have painted it as a waveform on canvas. Musicians have turned its frequency into sound. Writers have woven it into novels, short stories, and films. In these works, the wow signal becomes more than data, it becomes metaphor. A symbol of longing. A whisper from the unknown. Proof that silence can be broken, if only for a moment. Jerry Emmon himself often downplayed the drama of the moment. He insisted he never actually exclaimed, "Wow." That the famous note was more of a shorthand than an outburst. Yet the symbol stuck. Across the world, people saw in that word a reflection of their own awe. It was less about what Emmon felt than what humanity felt: astonishment, wonder, a childlike gasp at the possibility of company in the stars. The wow signal has slipped into popular culture in subtle but persistent ways. Science fiction authors have returned to it again and again. In novels, the signal often becomes the first contact moment, the spark that sets humanity on a new path. Some stories imagine it as a call from benevolent beings, others as a warning, still others as an accident overheard. In each retelling, the wow signal becomes a mirror of our hopes and fears about the other. Musicians have transformed the raw numbers, 6EQUJ5, into melodies. Electronic composers have sonified the signal, turning radio static into haunting tracks. Visual artists tattoo its jagged printout onto skin, carve it into sculptures, painted on murals. The waveform has become an icon, recognizable even outside astronomy circles, a minimalist emblem of the question, are we alone? Though rarely named directly, the WOW signal echoes through countless portrayals of first contact. From Carl Sagan's Contact to more recent series like Arrival and Cosmos, the idea of a sudden, inexplicable signal from the stars continues to shape how storytellers imagine alien communication. The legacy of the WOW signal is not just cultural, it is philosophical. It asks us to consider our place in the cosmos in new ways. Why, if life is common, do we hear nothing? The WOW signal complicates this question. It is not silence, but it is not conversation either. It is the in-between, the tantalizing possibility that voices exist, but remain fleeting, fragile, or far away. The event also raises questions about how we treat rare evidence. Do we demand repeatability, or do we allow ourselves to take seriously the one-time anomalies? In life, as in science, we are often given just one chance, one glimpse, one whisper. The WOW signal forces us to wrestle with the weight of single moments. Finally, the WOW signal reflects our need to find meaning in randomness. A burst of radio static becomes, in our minds, a message. This may be illusion, or it may be insight. Either way, it reveals that we are creatures of interpretation, unable to leave mystery unexplored. Technologically, the WOW signal also changed how SETI designs its searches. Improved recording. In 1977, data was logged on printouts. Today, signals are digitally stored, allowing researchers to replay, reanalyze, and share them. Wideband searches. The WOW signal encouraged broader frequency monitoring. No longer do astronomers focus narrowly, they scan millions of channels simultaneously. Instant verification. Modern arrays can trigger rapid reobservation, minimizing the risk of one-off mysteries. Yet even with these advances, no signal since has matched the WOW signal's intrigue. We are better prepared now, but the universe has remained quiet. The WOW signal stands as a reminder that sometimes, the most important events come before we are ready. For Jerry Emin, the WOW signal became a lifelong companion. He often found himself in interviews, conferences, documentaries, asked again and again about those 72 seconds. Though he remained cautious, always reminding listeners that he did not believe it was definitely extraterrestrial, he could never escape the association. The WOW signal was both a burden and a gift. A burden, because it demanded answers he could not provide. A gift, because it connected him to something larger than himself, a mystery that belonged to all of humanity. For the volunteers and scientists of SETI, the WOW signal provided motivation. For the skeptics, it provided fuel for critique. For the general public, it provided a story. Everyone found in it what they needed. Today, students who were not yet born in 1977 study the WOW signal as a case study in astronomy. Many are inspired by it to join the field. They see in it not just data, but drama, a reminder that the universe is not a static textbook but a living, breathing mystery. The signal also continues to drive public support for SETI. Crowdfunding campaigns, citizen science projects like SETI at home, and public lectures often invoke the wow signal as a hook. Its mystery still sells the dream of listening. In the end, the legacy of the wow signal may not be about aliens at all. It may be about us, our hunger for connection, our refusal to be satisfied with silence, our willingness to let imagination flourish in the gaps left by science. The signal reminds us that humanity itself is a signal, fragile and fleeting. Our radio waves are leaking into the cosmos, faint but real. One day, another civilization might notice a strange burst of energy, circle it on a printout, and write their own version of wow. In that sense, the legacy is circular. We are both the listeners and the broadcasters, both the seekers and the mysteries to be found. The wow signal is not a solved puzzle but a story. Its power lies in its incompleteness, in the way it resists final explanation. It remains the perfect metaphor for the search for extraterrestrial intelligence, full of hope, full of doubt, balanced on the razor's edge between science and wonder. When future historians look back, they may not remember every telescope or every data set. But they will remember the wow signal, not because it gave us contact, but because it gave us something equally important, the courage to keep listening, even when the universe answers only with silence. It has now been half a century since the night the Big Ear radio telescope caught that curious burst from the stars. 72 seconds, scribbled onto a sheet of paper, circled in red ink, and immortalized with a single word, wow. 50 years have passed. Half a century of listening, searching, and wondering. The world has changed in ways Jerry Emmon could not have imagined in 1977. We have mapped thousands of exoplanets, discovered oceans beneath icy moons, and sent probes beyond the heliosphere. We carry in our pockets more computing power than the machines that once processed Big Ear's data. And yet, for all this progress, one thing has not changed: the wow signal remains the most tantalizing unsolved mystery in the history of the search for extraterrestrial intelligence. It has become a milestone, a cultural relic, a question mark suspended in time. This chapter looks back at the 50 years since the signal was first heard, tracing its legacy across science, society, and imagination. To understand the weight of 50 years, one must recall the world of the wow signal's birth. In 1977, humanity was just learning to reach beyond Earth. The Voyager probes had only recently been launched, carrying with them golden records of our existence. The first personal computers were arriving in homes. The Cold War shaped geopolitics. And in astronomy, exoplanets were still theory, not observation. The Big Ear telescope itself was a relic even then, a massive, static structure built on farmland in Ohio, designed more for surveying radio sources than for listening to alien civilizations. Its computers were primitive by today's standards. Data spilled out not as waveforms or audio files but as rows of alphanumeric codes on fanfold paper. Yet within that crude machinery, something remarkable occurred, a signal so strong, so clean, that it stood apart from the noise of the universe. The decades immediately following the wow signal were defined by both excitement and frustration. Repeated attempts to relocate the signal failed. Astronomers pointed Big Ear, Arecibo, and other observatories toward the same patch of sky, waiting for lightning to strike twice. It never did. Skeptics argued that the signal must have been terrestrial interference, or some unknown natural phenomenon. Believers insisted it might have been a fleeting transmission from an alien probe, never repeated. Still, the memory of that night fueled SETI. Carl Sagan's Cosmos, 1980, presented the search as noble, rational, and deeply human. When Sagan's novel Contact, 1985, was published, and later adapted into a film, 1997, it was hard not to see echoes of the wow signal in the story of a scientist who receives a message from the stars. The wow signal became part of the mythos of the late 20th century, a symbol of cosmic possibility, hovering between hope and silence. The 1990s brought a discovery that would forever change the way we interpret the wow signal, the first confirmed exoplanets. Suddenly, the universe was no longer assumed to be filled only with stars and barren rocks. Planets were everywhere. Today, we know of more than 5,000 confirmed worlds, with estimates of hundreds of billions across our galaxy. Some are hot Jupiters, others frozen giants, but a precious few sit within the habitable zones of their stars. In 2017, on the 40th anniversary of the wow signal, scientists confirmed that within the very region of Sagittarius where the signal was heard lies a sun-like star, 2-mass 19281982-2640123, orbited by at least one planet. Coincidence? Perhaps. But for those who see in the wow signal more than noise, it was a tantalizing connection. Maybe, just maybe, the signal had a home. In 1998, the Big Ear telescope was demolished, replaced by a golf course and housing development. A piece of history was gone. The destruction sparked outrage among astronomers and dreamers alike. How could humanity tear down the very instrument that had heard the closest thing to a cosmic greeting? But funding was scarce, and priorities shifted. Still, the wow signal survived. Its legacy moved beyond any single telescope. It became part of the broader search, a story told in classrooms, documentaries, and late-night debates. The new millennium brought technological leaps that transformed SETI. Distributed computing projects like SETI at Home enlisted millions of volunteers to process radio data from Arecibo. The Allen Telescope Array in California, though plagued by funding issues, was designed specifically for scanning the skies for extraterrestrial signals. The Kepler and TESS missions filled catalogs with exoplanets, giving SETI clear targets for the first time. In 2015, the billionaire Yuri Milner launched Breakthrough Listen, the most ambitious SETI project in history, committing $100 million to survey the nearest million stars. At last, resources were on par with the dream. Through all these advances, the wow signal remained the benchmark. Every time a promising anomaly appeared, journalists inevitably asked, "Is this the new wow?" None ever were. Now, 50 years later, in 2027, the wow signal is both history and living memory. For scientists, it is a case study in anomaly detection, a reminder of both the possibilities and the limitations of data. For the public, it is a symbol of wonder, a story told with equal parts science and poetry. For SETI, it is unfinished business, a whisper that keeps the headphones on, the telescopes pointed outward, the software scanning. The world itself has changed in ways that affect how we view the wow. Signal. Artificial intelligence now helps comb through data in ways unimaginable in 1977. Space telescopes peer into exoplanet atmospheres, searching for biosignatures. Private companies plan missions to Mars and beyond. Humanity is no longer confined to dreaming, it is preparing to become interplanetary. And yet, for all this progress, the stars remain silent. The wow signal has not been repeated. No unambiguous alien message has been received. We stand on the cusp of cosmic expansion, but still we wonder if we are alone. Looking back, the wow signal has shaped not just science but philosophy. 1. The lesson of patience. The signal taught us that answers may not come quickly, or at all. Science is not always a march of progress, sometimes it is a meditation on silence. 2. The fragility of evidence. A single event, lost in time, can change the course of thought. The wow signal reminds us to preserve our data, to respect anomalies, and to admit when we do not know. 3. The mirror of humanity. The signal reflects our own desires. Whether or not it was extraterrestrial, our response to it reveals much about us, our hunger for connection, our fear of isolation, our tendency to turn mystery into story. Few scientific anomalies have left such a cultural footprint. In music, bands and composers have turned the signal into albums, tracks, and motifs. In art, the jagged printout has been painted on murals, tattooed on skin, carved into sculptures. In fiction, from novels to films, the wow signal reappears as the archetype of first contact. It has become shorthand to say, the wow signal is to evoke the entire human longing for cosmic neighbors. If the last half-century has been shaped by the wow signal's mystery, what of the next? Perhaps in the coming decades, a new signal will arrive, longer, clearer, unmistakably artificial. Perhaps we will learn that the wow signal was a false alarm, its mystery unraveled by new understanding of natural radio bursts. Or perhaps it will remain forever singular, a ghost in the cosmic static. Either way, its impact endures. The wow signal will remain a catalyst, a story that fuels the courage to keep listening. 50 years ago, a young astronomer circled a set of numbers and letters, and with one small word, he captured the essence of humanity's awe. Wow! It was the sound of wonder, the sound of possibility, the sound of an entire species realizing that the universe might not be empty. Half a century later, we still live in the echo of that word. And perhaps, in the next 50 years, the echo will find its answer. For 50 years, the wow signal has hovered between the categories of noise and message, accident and miracle. Most scientists remain cautious, some skeptical, a few quietly hopeful. But let us suspend disbelief for a moment. Let us ask the question that haunts the imagination. What if, on August 15, 1977, the Big Ear telescope truly caught a whisper from another civilization? What if those 72 seconds were not random noise, not a stray signal from Earth, not the hum of a passing satellite, but an intentional transmission, aimed across the void, reaching us after perhaps thousands of years of travel? What would it mean? If the wow signal was real, then Earth has already received its first message from another intelligence. Not a long, structured transmission filled with mathematics or star maps. Not a greeting in multiple languages, nor a golden record sent in reverse. Just a single burst of radio, narrowband, strong, clean. It might have been a beacon, a ping sent out to announce presence. Or perhaps it was the edge of a much longer transmission that we missed. Maybe it was an accident, a leak from another world's technology, as unintentional as our own television and radar signals leaking into space. Either way, it means that we are not alone. The silence of the cosmos was broken, if only for a moment. If the wow signal was genuine, it would revolutionize every field of science. Astrobiology would no longer speculate about the existence of life, it would shift to understanding the nature of alien life. Astronomy would have a new target, the region of Sagittarius where the signal originated, possibly tied to a star system with planets. That sky would be mapped, monitored, studied with relentless precision. Physics would have to account for the implications. How strong was the transmitter to be detectable across such distance? Could it involve technologies we cannot yet imagine? Computer science and AI would be mobilized to search old and new data for hidden patterns, in case the signal contained more than we realized. The discovery would ignite a scientific arms race of curiosity. Governments, universities, private enterprises, all would pour resources into decoding and replicating the feat. The wow signal, if real, would also reframe the Fermi paradox. For decades, we have asked, where is everybody? If life is common, why don't we hear from it? Why do the stars remain silent? The wow signal suggests that they are not entirely silent. Instead, perhaps we simply caught one of the rare sparks in the darkness. Civilizations might transmit only briefly, or rarely, or in ways we have yet to tune into. Perhaps most messages are missed because we are not listening at the right time, or with the right instruments. In this view, the wow signal was not an anomaly, it was a clue. A sign that the universe does speak, but only in whispers. If confirmed, the signal would force humanity to confront profound questions. Are we still special? For centuries, humanity has struggled with its place in the cosmos. The Copernican revolution dethroned Earth from the center of the universe. Darwin's theory showed we are animals shaped by evolution. The wow signal would add the next humbling truth: intelligence is not unique to Earth. What is civilization? If others exist, how do we define ourselves in relation to them? Are we advanced, or primitive? Are we part of a galactic community, or still children on the edge of awareness? Theological responses. Religions would grapple with the implications. Some might embrace it as proof of divine creation's vastness. Others might resist, fearing it undermines doctrine. Entire faith traditions could be reshaped by the knowledge that we are not alone. Existential meaning. For philosophers, the wow signal would spark debates about purpose. Are we destined to connect? Or doomed to miss our cosmic neighbors, forever chasing echoes across space? Imagine the geopolitical consequences if the wow signal had been confirmed as real in 1977, during the Cold War. Would the US and the Soviet Union have competed for ownership of the discovery, claiming first contact as a national achievement? Would the signal have been classified, hidden from the public for fear of destabilization? Or would it have sparked cooperation, forcing rivals to work together on a problem that transcended borders? Even today, the confirmation of extraterrestrial intelligence would shake politics. Nations would scramble to build new observatories, draft protocols, debate whether to reply. The United Nations might attempt to form a unified response, though history suggests that consensus would be fragile. The question of who speaks for Earth would become urgent and contentious. One of the most haunting implications is this: what if the wow signal was only the beginning of a conversation? Suppose the transmission was followed, years later, by another pulse, another message, aimed in the same direction. But by then Big Ear was dismantled, and no one was listening. Suppose the conversation continued without us, missed because our ears were turned away. In that case, the wow signal is not just a message. It is a reminder of opportunity lost, of a window opened and closed before we understood its significance. It is the story of humanity failing to notice when the universe reached out. If the signal was real, what does it tell us about its source? Power. To be detected at Earth across light years, the transmitter would likely need to be enormously powerful, perhaps orders of magnitude beyond our most advanced radio arrays. Precision. The narrow frequency suggests intentionality, as natural phenomena rarely produce such a signal. It would require sophisticated engineering. Purpose. Was it a beacon, a deliberate attempt to say, "We are here"? Or was it the spillover of alien communication, like our own TV broadcasts bleeding into space? Each possibility paints a different picture of the civilization behind it, either reaching outward, hoping to be found, or simply unaware that they had been overheard. If confirmed, the wow signal would evoke a spectrum of human reactions. Awe. For many, it would be the most profound moment in history, proof that the universe is alive with minds. Fear. Others would fear what it means. If they can transmit across stars, what else can they do? Are they benevolent or dangerous? Curiosity. Scientists, engineers, and dreamers would hunger to know more. What do they look like? What do they value? Are they like us, or utterly alien? Indifference. Strangely, some might shrug. In an age of information overload, even the most extraordinary discoveries risk blending into the noise. But collectively, it would be a turning point, the day humanity ceased to be alone. If the wow signal was real, then humanity's future will forever be tied to that discovery. Education would shift, emphasizing cosmic awareness, preparing children to think of themselves as part of a larger community. Exploration would accelerate, with missions designed not only to explore worlds but to seek their inhabitants. Unity and division would wrestle, some would call for global cooperation, others for isolation, fearing contact. Art and culture would flourish, inspired by the knowledge that imagination is no longer speculation, it is reflection of reality. The wow signal would become the cornerstone of a new era, the dawn of cosmic identity. So, what if it was real? Then the wow signal was not just a blip on a printout. It was humanity's first encounter with the other, the first brush with the idea that minds beyond Earth have looked outward, as we have, and that across the gulf of space, their voice reached us. If it was real, then we have already been welcomed into the universe. We just have not yet learned how to answer. And that is the haunting, beautiful truth. Perhaps the conversation has already begun, and the next word is still waiting in the stars. The wow signal is, in a sense, a lullaby. Not in the ordinary way, not like a parent singing to a child, or the familiar hum of a fan in a summer night's room. It is stranger, colder, more cosmic. But the effect is the same, a sound that arrives, unexpectedly, at the threshold between wakefulness and dream. On the night of August 15, 1977, the big ear caught a voice. Whether that voice belonged to another world or to the tangled noise of our own machines, we still do not know. What we do know is that it came and went, leaving us in a state of restless half-sleep ever since. The story of the wow signal is not just about astronomy or engineering. It is about longing. It is about the way humans fall asleep with questions still in their minds, questions that do not vanish with the day but return at night, woven into dreams. To call the wow signal a dream is not to dismiss it as unreal. Dreams are not false, they are real experiences of the mind, shaped by fragments of memory, desire, and possibility. The wow signal is like that, a dream of the universe, heard through a machine. When Jerry Emmons circled the 6 characters on the printout, 6EQUJ5, he did not know whether he was marking noise or music. But in that moment, humanity was given a dream to hold on to. Maybe we are not alone. Dreams are fragile things. They vanish when daylight comes, when we try too hard to pin them down. The wow signal has always resisted clarity. It is the dream that fades as you wake, leaving only the feeling behind. There is a strange comfort in not knowing. If the wow signal had been explained immediately, if it had been traced to a passing satellite, or to a flaw in the receiver, it would have been forgotten. A footnote in an engineering manual. But because it was not explained, it lives on. Its mystery allows it to remain more than itself, to serve as a mirror for our hopes. In this way, the wow signal comforts us. It says, "Sleep now, humanity. The universe is vast, and maybe you are not as lonely as you think." Like a child drifting off to sleep, humanity can hold on to that possibility without needing proof. The dream is enough, for now. Yet mystery can also be unsettling. When we lie awake at night, listening to distant sounds, sometimes they soothe us, and sometimes they remind us of how alone we are. The wow signal is both. It is the knock on the wall of our cosmic house. Was it a neighbor? Or only the settling of the wood? Loneliness sharpens in the absence of an answer. The signal came once and never again. It did not repeat, did not explain itself, did not soothe us fully back into sleep. It left us listening harder, straining for another sound. To fall asleep with the signal is to fall asleep with loneliness, comforted by the possibility of company, but aware of the silence that follows. Every culture has lullabies, and every lullaby carries a story. Some are soft tales of comfort, others warnings in disguise. The wow signal has become our global lullaby story. We tell it again and again. A lonely telescope heard a whisper. A scientist circled it in astonishment. For 72 seconds, the universe seemed to speak. Then silence. The story is told in classrooms, in documentaries, in novels and films. Each retelling is another attempt to cradle the signal, to rock it gently in memory, to make sure we do not lose it. We sing it to ourselves, and in doing so, we fall asleep not in despair but in wonder. The wow signal is not just data, it is emotion encoded in numbers. Why did we respond so strongly to it? Why did a single unexplained spike in radio frequency capture imaginations for decades? Because it spoke to something deeper than science. It resonated with our longing for connection. It became not just a radio signal, but a metaphor for love, for faith, for the endless search for companionship. We have all had our wow moments in life, brief, unrepeatable flashes of beauty or contact, too fleeting to hold. The universe itself has now shared one with us. When we speak of sleep in relation to the wow signal, we do not mean only literal rest. We mean the state humanity inhabits, a kind of cosmic sleep, half aware, half dreaming. We are infants in the universe, barely awake to its scale. We lie in our cradle of earth, listening for sounds outside the window. The wow signal was the first creak of the floorboards, the first rustle of the curtains. We rolled over, opened our eyes for a moment, whispered, "Wow," and then, unsure of what it meant, we drifted back towards sleep. The tragedy of the wow signal is not just that it disappeared, but that we allowed it to fade. The big ear was dismantled. Funding for SETI has waxed and waned. Entire decades have passed with only scattered efforts to listen deeply. Humanity has fallen asleep again and again, lulled not by answers but by distractions. The wow signal has become the bedtime story we tell instead of continuing the search. It is easier to dream than to labor endlessly for confirmation. But every dream leaves an imprint. Even if we sleep, the memory of the signal stirs in us, waiting for the next time we wake. There is tenderness in the unknown. The wow signal asks nothing of us except to wonder. Unlike war, unlike politics, unlike the crises of daily life, it makes no demands. It simply exists as a quiet gift, a soft reminder that the universe is not fully mapped. To fall asleep with the signal is to accept that we cannot know everything, not yet. It is to rest in the arms of uncertainty, trusting that some mysteries are worth carrying unsolved. Like a child trusting a lullaby without asking the meaning of every word, we can let the wow signal rock us into peace. Every night, humanity carries questions into sleep. Will we survive the challenges of our own making? Will we reach the stars? Will we ever meet the others, if they exist? The wow signal joins these questions. It lies beside us as we sleep, neither confirming nor denying, but reminding us of possibility. It is the unanswered question we whisper to ourselves before drifting off. What if that was them? What if we are not alone? Picture this: Earth turning slowly, night sweeping across continents. Billions of people lying down, one by one, falling asleep. Above them, the stars shimmer with ancient light. Somewhere in Sagittarius, perhaps, a transmitter lies silent, or perhaps still whispering, unheard. The wow signal is the lullaby of this scene, a 72-second song that reminds us, even in silence, that the universe is listening too. And so we fall asleep with it, not in despair, not in certainty, but in the sweet, restless space between. The dream is not finished. But we are still dreaming.